Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I am going to recap what we have learned in Chapter 4. Chapter 4 is about energy analysis of closed systems. It covers part of the learning outcome number 2 of our course, which says that you need to be able to describe and apply the first law of thermodynamics to study closed systems. So what do you need to know from Chapter 4? Or first, what is moving boundary work? Second, energy balance for closed systems. And then you need to know what is specific heats. You need to know what is the relationship between internal energy, enthalpy, and specific heats of ideal gases. And later you're going to expand that to incompressible substances. Moving boundary work is basically the expansion and compression work in a piston cylinder device. It is being denoted as W sub B, and it is equals to the integration of pressure multiplied by the displacement of volume as your process goes from one point to another, from one condition to another condition. So your moving boundary work is positive if you have an expansion, and it is negative when you have a compression. This is due to the displacement of your volume. And your moving boundary work is actually also equals to the area under your process path, because the area under your process path is actually equals to the integration of the pressure multiplied by the displacement of the volume. Okay, next is about your energy balance for closed system. The energy balance for closed system is basically this equation here, where you have E in minus E out equals to delta E system. The E in minus E out for your closed system represents the heat coming in into your system, and also heat coming in and out of your system, and the work coming in and out of your system. Okay, in and out. And then for your delta E system, it should represent your change in internal energy, change in kinetic energy, and change in potential energy. Okay, I'm not gonna go all over the slides again because this is just a recap, but I believe on the notes that we have discussed before, you should know what it is. Okay, next thing, it should be the specific heat. And specific heat, there are two types of specific heat. One is specific heat at constant volume, where we denote that as C sub V, and another one as specific heat at constant pressure. Okay, and then we're going to see the relationship between internal energy, enthalpy, and specific heats. So if you see here, the change in internal energy, the change in internal energy is actually equals to the integration of your specific heat at constant volume, and the change in enthalpy is actually equals to the integration of the specific heat of your at constant pressure. Okay, and this will be extended to the relationship of internal energy, enthalpy, and specific heats of solids and liquids. What is important for solid and liquid is that the specific heat at constant volume and at constant pressure for incompressible substance are identical. It means that for incompressible substance, CV equals to C sub B. That should be all for the recap. Okay, thank you.